GigaMe Instructor Live Sessions. Today, we take a session on Find the frequency of the most frequent element in JavaScript.
Hi.
Hi. Okay. So any interview happen?
No, I have it right on 14th.
You have it.
Okay, I think we didn't meet after that. So on Monday, they scheduled it for Geico. That is on 14th. Coding
Oh,
interview.
okay. Okay, then it is good. And this was C Sharp, right?
No, the role is actually C#, .NET, React.js, but the coding interview will be again like lead code. So I'm planning to do in JavaScript.
Okay, you're planning to do it in JavaScript.
Yeah.
Okay. Okay. And did you practice the questions?
Yeah. So I did threesome after that in a different way.
Okay.
So that was taking a lot of time actually, the one that I did.
Okay.
And then I did few sliding window problems like repeat the longest substring and one more I did like stock prices that you buy. And then one more like XOR problem using 2 pointers.
Okay.
This is what I did last 2 days.
Okay. All they all are, I believe, lead code problems only, right?
Yeah. I'm just picking like easy medium for now, and I was only doing 2 pointers and sliding window.
Okay. Today let's do one thing. I'm going to give you a few lead code problems. Do you want to do lead code problems or the GigaMe questions? I want you to do it in front of
So
me. I will give.
yeah, we'll do lead code, but I also saw a few lead code questions on GigaMe as well.
Yeah, there are.
Yeah. So now I was trying to do top K frequent elements.
Okay.
So I mean, I didn't know how to do it first because I was trying in a different way and it didn't work. So I saw a video in that he's actually using bucket sort, but then he is converting like you know the question, right?
Can you explain a little bit more?
Yeah, wait. So let's say we have a array like this: 2, 2, 3, and 4, and my k is equal to 2. I'll have to get the top k elements, top k frequent elements.
Okay.
So in this, it'll be 1 and 2 because 1 has occurred 3 times, 2 has occurred 3 times. So initially, I just I was able to count them and put it into the map. Can we not do it that way? So you just put it into map. Can you reverse the map and then just pick top 2 from that?
Reverse the map. Why do you want to reverse?
Sorry, not reverse. I mean, pick the order it in descending order. That's what I meant reverse, but that is for array.
Okay, descending order you means that it is going to be then put all the 111 and 22 simultaneously if they are not.
So if I create map, I'm going to have it like 1 has occurred 3 times, 2 has occurred 2 times, like this.
Yeah, you can also do that. The time complexity is going to be the order of n for this.
Yeah. So I have converted it into map. Then I don't know how to proceed it from there. So the way that guy does is, I don't know why he's using bucket sort here, but he's trying to convert this index as value and put this 3, 2 as index in an array. And again, there he is reversing the array and then he is giving the first 2 elements.
That is going to take a lot of time.
Yeah.
Map is taking order. But why you are like this key? It might be the possibility that he's not that approach that he's using. I don't know where you saw is not the best approach.
Yeah, so I don't know. I got confused and I stopped doing it. But then I was thinking
What
if
was the
we
time
just
complexity? Did you saw the program entirely and what was the time complexity for that? Because everything
oh,
depends upon time complexity.
yeah, so I got the catch here. So if the number is like 100 and but in map is just going to pick the numbers from the current array, right?
Mm-hmm.
Let's say I think that should be fine. Our approach should also be fine. I don't know why he took bucket sort.
You're saying that if
And
it
then
is going to be 100 in between.
yeah, if it is 100 in between, it's fine, right? You're just going to map it like 100 one or 100 two times, whatever, based on the frequency.
Yeah, it is going to pick up like that.
Okay, so now how do I manipulate this map? I'll
Manip
remove the, yeah, I'll just show you what I did
Share
maybe.
your screen.
I was trying to do the way he did, but now I want to change it. That's what sometimes we just, can you make me a host?
Oh, okay.
The more data structure, the more lead code you do, you always think in the data structure way. Sometimes it is possible to just achieve it uh, using a for loop or while loop. I feel it is more complicated.
Using for loop and while loop?
No, always thinking in the data structure way. Sometimes it can be solved just with for or while
Times,
loop.
yeah. I have also
And
seen that sometimes even if the problem can be resolved in a very better way, like in a
yeah,
very easy way, they are using a very hard method to achieve that. And
yeah.
it's a lengthy one.
Yeah, so I get confused. So I don't know if I'm stuck somewhere, I just go and check for some videos. Each of them have their own thing. Someone will say, so one of the problems I was able to do it with two pointers itself. But then they were saying sliding window is more effective. I don't know why they need to use sliding window there. They don't give like
But they have
proper
not any explanation
examples.
for that.
No, they don't say. They just say we'll use sliding window. It is more efficient. That's it. And on lead code itself, few people have said this is just two pointers. It is wrongly tagged under sliding window. Okay.
It might be the possibility, like
I mean,
Abhinay,
it is
they,
possible to do it using sliding window as well, but I feel sliding window is little more complicated than
no,
two
that's
pointers.
fine. That's fine. What
There,
I'm thinking is that it might be the possibility that they are using this approach just to make sure that the learner, like whosoever is solving
yeah,
that problem, should know about these techniques as well.
yeah, right. Yeah, that's there.
I will. It has no relevance with the that whatsoever has the bacterial and optimum
Yeah,
approach.
even if
Just
it's graph, right,
hmm.
we can always use these pointers. That's what I was thinking. And in sliding window itself, the memoization concept comes, which is part of dynamic programming.
Mm-hmm.
And in two sum, three sums, we can also like there are also sub programs, right? That is also part of dynamic programming. That's why
Correct.
they go. There is a roadmap. Like first you do all of these and then go to dynamic programming.
Mm-hmm.
Okay, so
Yeah, I see, Abhinya, that's how I see it, that whenever someone is taking a lot of time and the time complexity is, of course, also, let's say that the bucket will that sort, it is taking n log n, let's suppose. That I don't know
yeah, yeah.
what other things he has used. And your is taking order of n. By default, your is better than the previous one, right? So
I mean,
don't doubt on that.
I
Yeah.
don't know if my program will work anyway. Let's try it now. If it works and if my runtime is less, then I will just follow this. I'm not going to make it complicated.
Okay, execute this. This is the program that you created, right?
No, this is not finished yet. So I'm going to delete all of these. So I didn't know how to convert the way he did. So what he did, now I have created the map.
Mm-hmm.
Okay. So this is going to have that key and values. And then again, he told me that put all the values. No, the number of times that we get right, convert that into index of an array, and value should be the numbers, something like that. So I didn't know how to do that, how to convert it. I did not understand his code, so I don't want to like blindly copy or
No, don't
so
blindly copy anything, whatever is
yeah,
there in the
I
tutorial.
never do that. If I don't understand,
Yeah.
I just stop it there.
Yeah,
And
sometimes it also scratch like I'm also at the edge of scratching my head when I'm feeling like that what they are doing.
I don't want to mug up because I never do that. I just sit down, I write one by one, like even if it is taking time, I do the input calculation, output, move the pointers and see how it works on notebook or whiteboard. Only then I'll write program. I'll not directly write program.
You do also one
So
thing before starting that, like just look for the solutions for that particular lead code question because there are multiple solutions for a single question, in fact.
yeah, I know. Yeah.
Look for 5 or 6 or 7 or 8 at just a glance. Not,
Okay.
yeah, because now you know you are good in programming, right? So you know just by looking at it that okay, what solution or what type of thing they have used, correct?
Yeah.
So out of those, it will be in your mind, okay, this is, I believe, looking good or better as compared to others. So you can also do in this way.
Okay.
I have sent you one question. Can you open that?
Yeah.
Because there are thousands of questions even on this frequent.
Yeah, it is same kind, I guess.
It is same kind of question.
So, on operation, you can choose an index. No, this is bit difficult.
Yeah, because this input and
So in this, they are saying you have to do k operations and then uh, increment the element by 1. So 5 times you have to rotate, something like that.
mm-hmm.
Increment the first element 3 times and the second element 2 times to make the numbers. I don't know. What is this? I don't even understand the question.
4 has a frequency of 3. What is the output? 3. Okay, the frequency of an element is the number of times it occurs in an array, correct? Here, given an integer with array numbers and an integer k. In the
What's the number of
operation,
times?
you
So
can
one,
choose.
so 1 is occurring once, 2 is occurring twice, and then 4 is occurring 4 times. Is it like that? Is
Return
the
the
number of
microprocessor, you can say an element performing at most. Mm, from the example 1, they are just incrementing the 0th or the first index value. And in the second example as well, they are taking 4 and then 8
So
and
let's
then
first
13.
do this one and then we'll go to this.
This one is hard, right?
Medium only, but uh,
Mm. Let us understand this because we're
is
not.
this question frequent?
Sorry.
I mean, what is the frequency of this question? Like
Yeah,
here you, right?
let's understand this. So the problem statement, I believe, is describing a scenario. Go to that page only.
Yeah.
Yeah, but I believe that the problem scenario describes that where we have given an
Printing
array
the
of numbers n and integer k, we need to perform an operation where we can choose an index in the array and increment the element at that index by 1. The goal is to determine the maximum possible frequency range. Any element. Let's break down this. We have the input. They have given us the example of 1, 2, and 4. Let's say we are having 1, 2, 3, 4. And if
Increment the first element 3 times and the second element 2 times to make numbers 4, 4, 4. So we'll have to make it frequency of 2. Let's see the second one. 1, 4, 8, 13. Increment the first element 3 times to make numbers 4, 4, 8, 13. Element is the number of times it occurs in an array. So then 1, 2, 4 has occurred only once, right? The first line. Frequency of an element is the number of times it occurs in an array. So everything has occurred only once. 1, 2, and 4. Choose an
Acha,
index.
do one thing. 1 to 4 is equal to 5. To make 4 and 4 for the 0th and first index, how many times operations are being held?
3 times.
Is it? No.
First element is
is 1.
incremented 3 times.
3 times, right? And the second one is incremented
2 times.
2 times. So the sum is 5, right?
4, 5, 6, 7. Sum of what? Indexes?
Number, no. The sum of number of things
Yeah, that times. Yeah, 3
that is
plus
5.
2.
Yeah. Now look for the example 2 and see the same thing. That whether it is number of 5. See,
Times.
they have 1, 4, 8, 13, right? And the k is 5.
Yeah.
Now, in the explanation of first, they are making the first two elements 4, 4, 8, and 13. That means only the first one is changing.
Yeah.
Right. Now, to make this happen, the first one is taking how many iterations? 3 iterations, right?
1. Okay. 2 times, right?
3. 1 to 2. First it is changing, then 2 to 3, then 3 to 4. We are changing 1 into 4 now.
1 into 4 and 2 into 4. That's it.
2 to 3 भी तो
1
जाएगा.
to 4, right?
No, I'm saying for the example 2.
So
Yes.
here?
Yes. So what I'm thinking that what is happening, it is giving you a like k value 5. It is asking you that this is the at most number of time you can increase, like you can perform the operations on any of the index value of the array and see that which number you can convert to any of the given numbers.
And make it occur one more time.
Yeah, whether it is 1 more time or 2 more times or 3 more times, and see that then how
And
many
then return how many times it has occurred.
Correct. Got it.
Okay.
Now look for the second explanation. Like increment the, at first, it is incrementing 4. Second, it is incrementing 8. Right? And how many times it has used this? Again, this is 4 times. That means none of the iterations are increasing 5 more than 5 times.
Okay.
And it might be the possibility that after that, no other number you are going to convert into 8. Neither you are going to convert it in 1. 1 from 1 to 8 because it is going to take 7 iterations, right? Neither you can convert 13 to 8 is also, in the decreasing way because that is also going to take 6 iterations. Right? So that's why the best approach that you can like suffice 5 or less than that, just to make sure that how the other elements are going to increase the value at any index so that it can match to any other of the other array element. Then to check that whether how many times that element is increasing. That's the question. Got it?
Okay, then why the moment you get another value, so if you do 1 plus 1, 2 is already there, right? So you can even stop there.
How?
So we'll have to do 5 repetitions. So that's why they are doing.
At most 5. It is not important that you have to do 5 by heart. It can be 4, it can be 3. 3 times.
Yeah, that's what I'm saying. Then if you just increase the first one, 1 plus 1 is 2, then I already have another 2. We can
Yes,
also
you can
stop
also
here
do
and
it.
then
Yes, that is
say
also going to be
output
the
2.
answer. That's the thing that they have done in the example 2. Look for the example 3, what they have given.
Okay, well, the third element, 5 times 2. Okay, yeah. So they are doing either this, this, this.
Are you seeing the example 3?
So in 3, they are not doing anything.
Hello?
Hello? Can you hear me?
Abhinya? Yeah. Yeah, I can hear now. In between, I was not able to. Yeah, example 3 I'm saying.
So in example 3, they are not doing anything. Case just 2. So even if you convert 1, I mean, if you add 1 to any
Nothing is
of the,
going to happen. Even if we are
yeah,
going to
then
convert
my
anything.
output should be 0.
No, it
Why?
will be, I believe, 1 because at least any whatever the elements they are
Okay,
having.
we have to return the number of operations that we have performed.
Return the maximum possible frequency of an element after performing k operations. See, that is the exact
Yeah,
thing.
so here it
Yeah, it
everything
is
is occurring
1.
only once. Okay.
Yeah, so that's why the answer is 1.
Okay.
Okay, the question is clear. Now read the question again.
Bro. Okay, they are just saying frequency of an element is the number of times it occurs in an array, correct?
Mhm.
Then the question actually starts from here. You are given
Correct.
in one operation you can choose an index. Okay, I can choose anything. Okay.
Anything,
And then
yes.
increment it by that index and then check if that particular number is there in the array, right?
See,
If it's
now,
there, then
see, in example 1, 1, 2, 4, let's say you have 5 operations to perform the increment part. Okay, then on any of the array. At first, you will look at the array, you will see that, okay, it is 4. Okay, so I have 5 operations to perform. So you will try to perform the operations on 1 to make it into 4. It has taken 3 times, right?
yeah.
Then you're going to, the remaining are 2 operations. Then you will move to the next index. And there you will see the element is 2. Okay, to make it or convert it into 4, you need 2 more iterations, right? You have already like finished all of your iterations plus the entire array. All the items of this array has been converted into 4, 4, and 4. Right?
Then we just come out of the loop.
Then you just come out
And
of it.
then, yeah, and then print the count.
But in this, while creating now it is us as human beings talking, right? But in the algorithm, we have to traverse through each and every element just to make sure that the next possibility, if there is any next element, if the
Yeah.
number of iterations are left, it might be the possibility that in the input there is 1, 2, 4. Let's say the
Yeah,
case
until
6.
the length.
Yeah, let's say no, not the length. It also depends upon the number of iterations that we have left. Now I'm giving you one condition. Suppose you have k is equal to 6. Okay. And you have the input value 1, 2, 4, and 3.
Okay.
Right?
Yeah.
So after 4, 3 is also there, that can be converted into 4 because you have left one iteration after suffice all the 5 iterations into the one and the second. Right?
Can you say that again?
See, I'm saying that instead of 1, 2, 4, you have 1, 2, 4, 3.
Yeah.
Okay. Fine. Let's say that the array is not in the sorted form. This is the because all the examples I'm seeing they have given in the sorted form. Okay. Let's say now it is 1, 2, 4, 3, and the k is 6. Okay.
Okay.
K is 6. So for the first, you have already performed 3 operations. For the second, you have already performed 2 operations to convert it into 4. Okay. That means
So
5 operations you have
already
already
5 is
performed.
done.
Now
Then I
only
can
1
do
is left.
only. Yes. Okay. Got it.
Then you will check again after 4th value. That means after index number 2 as well, you are going to check that whether there is one more element that on which if you are going to perform the last remaining operation and it is also going to be converted into 4, right? Then yes, it can be converted into 4 because the number is already 3. You just have to perform one more iteration on that to make it into 4. Then the answer would be the 4 has a frequency of 4.
Okay.
Got it or not?
Yeah. So how do we choose then?
Choose what? Yeah,
Choose
that's the
the.
algorithm that we need to create. It is going to like we
So is
have
this
to
what?
think
Heap.
along the perspective of the like algorithm that at first it is going to check for the length of the like array, or it is going to check for the k is equal sorry, iterations are already there. I think it will be easy for us to create a program if it is in the sorted form, because at that time we can judge, we can go from the we will not start from the 0th index, then we can start from the last index, because the last index is basically going to have the highest element, right? And that has the more chances that we can convert any of the index value into that number, right? Then slowly we are going to, when that part is finished for the last index, then we can slowly move towards the left side, right? And we also
Yeah.
have to
Yeah. Got it. Yeah. I'm
yeah.
just thinking how we will. So okay. Then in that case, let me
Let's do
take
it
this
as for
example.
sorted form only at first.
That's fine. So I'll take this one 4, 4, 8, 13. So if we are going from last, then we have to check if we can make the other elements 13. So let's say I'll pick 4. Then I can also find the difference of 13 and 4. So that will be what? 8. No, 9. 13. So that will be 9. But my K is 5. So I don't think I can make this 4 to 13. Then again, okay, so I'm sorry, I'm checking after it is done. But then do you think my approach is fine?
Can you repeat your approach? Yeah, putting all the
So,
iterations in a single element, right?
no. So let me, we'll take this one 1, 4, 8, and 13.
Okay.
So first we are checking with 13. So my first thing is 13, and I'll take the first element 1. And then I see I get the difference between 13 and 1, which is 12. But the repetitions I can make is only 5.
That's what I'm saying. That rather than starting from the first element, 0th element, why you can't start
Okay,
from
yeah.
the last
Let's say,
minus
okay,
one
minus
index?
2. N minus 2, I'll take 8.
Like let's say that you
Then,
have for loop I is equal to I is equal to 0, I less than array dot length, or I is equal to array dot length minus 1.
No, that is fine. I got whatever you say.
Hmm.
But you're saying we'll have to check if I'm picking 13, I'll have to check if I can make any of the other numbers 13, right?
I'm saying no. I'm saying
That is the question, right?
no. Yeah, question we have already understood, right? The approach I'm saying that you have taken the 13. Why you have chosen the 13? Because that is the last element in the sorted array that has the
Yeah.
highest possibility, right? Now, after 13, you start from the 8 value. That means if the length is, if we are having 0 to n minus 1 index, right? Start searching to find the difference from n minus 2, that is from 8. From 8, if you are going to see, if you're
Yeah,
going to add the k value 5
that's
into
what I
8.
said. I
Yeah,
think you did not hear me. So I said n minus 2, then we pick 8, and then we do 13 minus 8. So that will be 5. Then you check, you compare k and 5.
yeah,
Okay,
either you can do
here
13
my
minus
k
8
is say,
or 8 plus
sorry,
5 as well.
5. So we have to check whether the difference uh, is equal to, is less than or equal to 5, the k. If it is possible, then you make the iterations on that particular element alone and make it to 13. So this is the third answer which they are giving. This
Correct.
third one. I'm talking about the third one.
Correct.
And then let's say we pick 8. Then we
Hmm.
go to 4. Then we are
Correct.
able to, we can do it here as well.
Correct.
Like 4 times you just increment. Then
Correct.
again you go to 4. And then this is again under like k. So here also it is possible.
Yes.
So this is the logic I am talking about. Like after that, I
Yeah, yeah.
understood whatever you said. I am talking about the next step.
We are going to do that. Slowly, we are
Yeah.
going to like take the perform these on the array with the maximum length, right? You can also, instead of
So
13 minus 8, you can also like go for 8 plus 5.
yeah, that is also fine.
Yeah. Yes, this is the approach. That's why they have given the sorted array,
Hmm. Okay,
right?
so and out of that, so there can be multiple answers then.
I think these are the best like frequencies that they have given us. Other than these, no other frequency can be created for any of the element of this array.
Okay, so how many output? So now I said all the outputs here, like first one, okay, you can do only once. So if I make this, if I pick 8, then okay, then we'll not get any number that will get repeated. Okay, so we'll only have to see the number that will get repeated and return the frequency.
Let's
Understood?
yeah, that's
So,
fine. I'm thinking you were talking about the sliding window approach. Can we use it here,
yes,
right? To make the
yeah,
left with the right pointers to define our sliding window. And then we have already the number of operations. And then let's create the maximum frequency variable to keep the track of the number of operations performed,
okay.
right?
So
And
my base case would be
mhm,
the n minus 1 from last.
yeah, I mean, you can at first, uh, I think let's like take the left and the right pointers to define this sliding window. Okay. Then after that, like we can use the loop to traverse through the array. It will be easy. At every step, we are going to calculate the number of operations that needed to make the elements in the valid window,
Hmm.
right? And then if
Yes,
the number of operations exceeds the k, then we are going to move the left pointer to the uh, like um, further.
next value. And
Correct.
then, yeah, so,
Let's okay. Start writing the yeah. That is a better way. I believe. Sliding window has a complexity of, let me Google. I forgot. N log n. No. Yeah, n log n.
So you said we'll start from.
Okay. You have taken var max.
But so if we are doing left, right, then okay. But we said we'll be just going from here, right? N minus 1, N minus 2, right?
Why are you using for loop? Just use while loop.
How do you, oh, 1 minute.
You have left, you have right.
So left will be nums dot length minus 1. Sorry, minus 2. That will be my base case. Like the first one that we are doing, first window. If we are going from the end, not 0. Got it?
Yeah, I got it.
Size.
We can also like do this rather than you have given the left number size minus 2, right? And right as well. So rather than that, like I think the variable that you have declared left and right, there is just a difference of one number, right?
Mm-hmm.
Then why not to give 0, 0 directly to make the window size at first of 1 only? Then we are going to move iterate through the array, and then we move the right pointer to expand the window, while the left pointer like be like it is going to move only on the base of condition. If it is going to exceed n number of operations, then we can move ahead.
Then that is 2 pointers, right?
No.
Window means we are going to expand the window.
Yes.
If you are moving just one pointer, if you are keeping another pointer here, okay, you are saying, then in that case, if I'm moving from end, then okay, my left pointer will be here. I'll be increasing my left pointer. Okay, got it.
Got it. Then
Got
that
it.
is the easy way. So make the right as well 0.
Okay. No, but right should start from the end, right?
Let's make it 0 in the start. Then slowly we can increase.
Okay. No, but if both are 0, how will it get into the while loop?
So there we will I'm thinking of taking 2 while loops. The first like this is
So
the
how I thought, okay, let me see.
see if here while
Think this is
is
fine.
less
Okay.
than numbers of length, let's say.
I
Right.
plus plus, then inside this, do your while. Here you make the left as 0. Right will be num size minus 1. Then inside this, we are going to check the, let's say I'll go this way, difference. Then nums of right minus nums of left. Then if that particular difference is less than or equal to k, then we'll have to again so we are picking right now I'm picking only one value, that will be nums of left. So inside this I'll have to make another loop.
Okay, so left and right we have taken 0 for I is equal to 0, I less than number size. Achha, you have taken the length there, okay. Okay. Have you taken any variable to count the number of iterations as well? You have not, right?
That will be getting it in the input, right? Okay. No.
Oh, we also need to count that how many we have already used,
Iteration
right?
count. I will make it iteration.
Iteration count, correct. And then also take, I believe, one more variable to like put the number of frequency for a particular.
To return. Okay.
Yeah.
Name it this way. Do you have another call after this?
Yes.
I feel 1 hour is not enough.
To solve such type problems, of course, it is less because at first you need to understand the lead code question. That is a task.
Yeah.
At first you will never.
That's why it is difficult to, even in interview, that's the issue. We'll have to keep on practicing for months and months, then we'll get it. Okay, so now
Or and this.
so I have to iterate difference time.
See, at line number, remove the line number 15 and 16.
Okay.
Right here, iteration count plus is equal to if I'm going to take the number of I is right now 0, correct? Number of I minus number of I minus 1 into I minus left. Just 1 second, Abhinay, I need to recharge my laptop. Charge it. Sorry. Just 1 second. Yes. Okay. So iteration count is plus equal to number of I minus number of I minus 1. Put this in round bracket. I mean, I'll tell you that what I'm trying to do here. If we're going to calculate the amount of change at first needed for the element within the sliding window to become equal to each other.
Yeah, that's what I'm doing it here, right? Difference.
Okay. Yeah.
And then I'm comparing it with difference. I think this can be done with 2 pointers itself. Because sliding window, you usually manipulate all the elements that's there in that particular window. So if you're starting with 1 4 8 13, you'll have to check everything. Like, let's say there is another problem which I did with sliding window. So you'll be checking, you'll have to return some kind of pair that will give my
Yes.
target sum. So that time you'll be doing 1 plus 4 plus 8 and then check if my value is equal to that. Then again 1 plus 4 plus 8 plus 13. Then if it is greater than or like binary search you do, then you shrink
So
the
by default, it
window.
is using both, I believe. It will use both by default.
Yeah, I don't know.
Yes, yes.
I can do it with 2 pointers itself, I feel. I don't know how it is done with sliding window, because my understanding of sliding window is that when you are in a window, you'll be using all the elements in that particular window for manipulation.
See, we are starting from 0, 0, right? From the
But
scratch.
here we are choosing only one element at a time.
At a time. Yes, that's what I'm saying. That let's say the left pointer moves to the right when the number of operations exceeds, right? The limit. Ensuring also that the window size remains optimal for the maximizing the frequency of the elements. Then it is this is I think going to be a combination of sliding and two window problem.
Okay.
um you have taken the I is equal to 0 and as the number size I plus plus. Then operations to calculate and adjust of the left pointer if it is required.
So here I got it. What we need to do is, if let's say I'm picking 1, okay, 13 minus 1 will be 12. So I can never make 1 as 13 because I can only do k operations. Then you shrink this window and remove the left element from that particular window and then try for 4. Then again you check with the k. If you're not able to do it with 4, remove 4, like move your left pointer, like increment your left pointer. So this is
Correct.
how you can do with sliding window.
Correct. If we are going to make it equal to the 13, right? The maximum are 5. The 5 plus 1 is never going to be 13. Remove it. Increase the left pointer.
So yeah, so we don't even have to do iterations here. So here I am checking difference, right? So if
Yeah.
the difference is less than or equal to k, then I'm going to do left plus plus.
You are starting from, just make sure that we are starting from the first.
So this is not needed now.
Yes. And in that case, then you also have to make right is equal to numbers dot length minus 1.
Yeah, that's what I did before.
Yeah.
That's why I did that. So right is equal to nums of
Declare
nums.
it at line number 10 only. Use directly from there.
Okay. But yeah, it should be outside.
And in JavaScript, let me tell you one more thing. In front of interviews, never use where. Always use
Okay.
let.
Yeah. I always forget. It should always be let, right?
Yes, because it has the lesser chance of
Yeah.
redeclaring.
So this is the issue with working on multiple programming languages. On C#, it is always where. But this where is right because it's inside this block.
Yeah, so what it is, it can be changed outside. Where you can access it anywhere outside, just you cannot access the where
So
outside function.
okay. Now
Okay.
else.
I is equal to 0 less than number size.
Now I'm shrinking
For 14,
this.
write number size -1. That is going to otherwise give a problem. At line number 14.
Okay, yeah, got it. The segmentation error will be there.
Left is less than right. That is correct. Let difference is equal to
I should only check.
numbers of right minus numbers of left. Correct? Okay.
If it's greater than k, then I'll do left plus plus.
Correct.
Else, else all you need to do is, but then
Else if, then you also need to create one more if. Else if, now we have to see that if after performing the 5 times iterations, whether that number of left has become equal to number of right.
So first we need to perform the action, right?
So rather
That
than that,
we
why
will do
can't
in
we,
the else. We
Abhinya,
can
rather
just
than,
directly add the value, right? Instead
yeah,
of,
yes, that's what I'm saying, that rather than seeing the difference, we
don't
can
have
also
to do any loop here. Yeah. So here, you could just do
if
what that value. No, let me first do this. Else, if
number of left plus k,
if it is equal to k, we need to have 3 conditions.
yes,
If it is equal to k, then
increase number of left by k times, and then
yes,
increase the frequency, result
left
frequency as well.
is equal to nums of left plus k.
Correct.
Okay.
And then increase the
Then
result frequency count as well. Right?
yeah.
But all this is happening just for the number of right only.
Right now it is happening only for one element. Then now we'll have to decrement right as well.
No, why there is a need of decrement? Acha, in that sense, yeah.
What if we don't get for 13? We'll have to check for other element as well, right?
Right.
I think I almost have the idea now, like how sliding window algorithm works, but it is going to take time for me to implement it like from the muscle memory. So then if it is less than k, I think like for the first one, so we can also divide the number of iteration, right?
See, let's say
Because see here in the first thing, 1 plus 2 they are 1 plus 3 they do, and then 2 plus 2, which means they are dividing this k. So here now I need to check if my difference, let's say 4 minus 1 is 3. then I'll have to decrement it from k. My updated k will be only 2.
Yes, correct.
So
Then you have
k
to
is
return
equal
from
to,
after, like you have to break. We cannot use break in if, but you have to return after if condition. Then it should not
okay,
check for the 25 line number onwards as well, right?
break won't work like this. It will, right?
Break won't work. No, no, it doesn't work in if conditions. You have to think of something different so that it won't go for the next number of lines.
Okay. But anyway, it's an else if, right? So anyway, it will not come inside this if this condition is not satisfied.
Hmm. Which
So
condition?
we don't have
25?
to break it.
Okay, yeah, continue.
So my k will be k minus, I forgot. How did we do? Yeah, k minus difference. We have got only 1 minute.
Yeah, but at least you got the idea now, right? That how it
Yeah,
can
I
be done,
will I will
right?
finish this. Yeah.
Yeah, so
Okay. What is your feedback
for,
for me?
yeah,
Like if
see,
I'm able to solve the problem or not, at least
yes,
up
you
to a
see,
level.
yeah, you can solve the problem. Like, I think where you take the time
Is
is
understanding?
understanding the problem.
Yeah.
Yes, that is where you always get stuck, I believe. Then after that, if it is there in your mind, then you can quickly make it up that, okay, what approach you're going to use.
Yeah,
Let's say
but
there
sometimes I also get stuck in with syntax. Then how do I do the loop? Literally everywhere.
syntax,
But
for
okay.
syntax, you have to practice. But yes, let's say that they have given you just 40 minutes of 30 minutes to do this,
Hmm.
right? At first,
Yeah.
like we should calm yourself after seeing the number like they have given you, right? The time. Then after that, try to understand the problem first, right? Take 5 minutes, that is fine because the way you do the code, I think that you can write the code like very easily, like quickly. So after
Hmm.
that, try to write the solution with pen or paper because that is easy way for us to do.
Yeah, so will they allow in the
Y-
interview?
Yeah, for the interview, I'm saying, like just like in the layman language, just see that how what approach you are going to use, just for the approach sake.
Yeah,
Then after
yeah.
that, start writing the code. Then you will like stuck very less while writing the code because you will knew before that what type of approach you are going to use for to solve this problem.
Okay. So that's what I usually do, but I don't know if they allow it in the interview.
Mm-hmm. They don't
I
allow
have, okay, okay.
the pen
Okay,
or
yeah,
paper.
I'll try it next time. I'll just show them. No, sometimes they'll think that we are cheating. Then, okay, someone,
You can like lower down your what you can say,
camera. Yeah, yeah.
camera. Yeah.
Okay. Okay, yeah, I'll try solving this. Yeah. Thank you. Thank you very
Okay.
much.
Okay then. Bye bye.
Yeah, bye. See you.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.